Hello dear students, today we are going to study our next chapter is stereochemistry of organic molecules. I think you know already stereochemistry means what. So stereochemistry is a branch of chemistry which involves the study of the relative special arrangement of atoms that form the structure of molecules and its manipulation. So we are going to apply the stereochemistry to the organic molecules. So here in this chapter we consider cycloalkanes. So cycloalkanes are the aliphatic cyclic compounds. So these are formed as a result of ring closure of alkanes with three or more carbon atoms. So we are represented as CnH2n. So here N means 3, 4, 5, etc. So example for cycloalkanes are cyclopropane, cyclobutane, cyclopentane, cyclohexane. So we already told that the carbocyclic or homocyclic compounds having a closed chains or ring of carbon atoms. So closed chains or ring of carbon atoms bearing a certain resemblance with aliphatic compounds in properties. So those are known as alicyclic compounds. So here we already told that alkanes with a three or more carbon atoms. So here three or more carbon atoms form a ring structure. So they may be simple saturated or unsaturated hydrocarbon or compounds having a different functional group also. Functional group means alicyclic alcohols, aldehydes, ketones, acids, etc. So this is about cycloalkanes. So next one is occurrence, where we get these cycloalkanes. So alicyclic compounds occur widely in nature. 5 and 6 membered cycloalkanes occur as a naphthenes in petroleum. So here naphthenes consist mainly of cyclopentanes and cyclohexanes together with a small percentage of naphthenic acid, which are cyclopentane monocarboxylic acid. So these are occurrence of our as alicyclic compounds. Next part is nomenclature. So here the number of in common name, here the number of carbon atoms forming the ring is indicated by a Greek or Latin prefix. So Greek or Latin prefix means here C3H6. Here the number of carbon atoms are 3. So here prefix is added trimethylene. So similarly C4H8 4 number of carbon atoms are 4. So here added prefix tetramethylene. So next one is C5H10 pentamethylene. Here tri, tetra, penta, these are Greek or Latin prefixes. So this is a common name for C3H6, C4H8 and C5H10 and so on. So similarly, next in IUPAC system, they are known as cycloalkanes. The name of cycloalkanes are derived from corresponding alkanes and the class name cyclo is prefixed to it. So here C3H6. So they form a ring structure. So cyclo next C3H6 it is a propane, cyclopropane. Similarly C4H8 cyclobutane. Similarly C5H10 named as cyclopentane and so on. So here comparison between common name and IUPAC name. This is C3H6. In common name it is called as trimethylene. In IUPAC name it is cyclopropane. Similarly here for C4H8 tetramethylene in common name, cyclobutane in IUPAC system. So similarly here pentamethylene for C5H10 and cyclopentane named in IUPAC system. So this is common name and IUPAC system. And next one is here one more point is there. Alicyclic hydrocarbons having one double bond are termed as a cycloalkenes, and those having two double bonds as cycloalkadienes. Two double bond, di means two, ins this preferred as for alkenes. So cycloalkadienes. So the position of the double bonds is specified by Arabic numerals. For example, here this is one molecule. This is one molecule. This is here cyclo. It is a cyclic structure, ring structure. Cyclo. There are 5 carbon atoms, so pents, and there is a one double bond. So that is suffixed as "-ene". So this is cyclopentene. Similarly, this is a cyclic structure, ring structure, cyclo, and there are 6 carbon atoms, hex, and there is a one double bond. So that is suffixed as "-ene". So this is cyclohexene. Similarly, here this is also same structure, these two, but here two double bonds are there. So cyclohex, and here the double bonds, the position of the double bonds is specified by Arabic numerals, means this 1, 2, 3, 4, 5, 6. First position and fourth position consist double bonds, so that is 1, 4 di, two double bond, diene. So this is cyclohexa 1,4 diene. So this is nomenclature of cycloalkanes. And similarly, relative stabilities of cycloalkanes. Here, all the cycloalkanes do not have the same degree of stability. The relative stability of cycloalkanes is determined by the on the based their enthalpies of combustion value. So, if the higher the enthalpy per CH2 group, means there is a lower is the stability. So, here the example for cycloalkanes, and these are the enthalpies with respect to these. So C3H6, this is a cyclopropane, the enthalpy is 697.1, and next one is cyclobutane, enthalpy is 685.7, and next C5H10, cyclopentane 664.0. So these are the enthalpy. So here higher the enthalpy, here C3H6 consists higher the enthalpy, means it is less stable compared to these three molecules. So similarly, next one is another way to explain the relative stability is with which the cycloalkane ring opens up. So lesser the stability of the ring, so that is very easy to open the ring. So if here the cyclopropane is a very small ring, so it is easy to open the ring. When it reacts with hydrogen molecule in presence of nickel at 80 degrees Celsius, it formed propane. Similarly, cyclobutane found butane, cyclopentane found pentane, but in cyclohexane, never ring opening, because stability increases with the size of the ring up to cyclopentane, and from cyclohexane onwards, all the cycloalkanes are quite stable, so there is no ring opening. So the stability of the ring increases as the ring becomes large. Therefore, stability of the ring is represented as cyclopropane has a less stable than cyclobutane, and cyclobutane has a less stable than cyclopentane, and cyclopentane has less stable than cyclohexane. So this is about stabilities of cycloalkanes.